There we go. X times x. X squared. Good. Okay. Basic one, right, from all your foiling days. Okay, that first foil is usually x times x, x squared. No big deal there, right? Okay, so let's change it up. What's x times x squared? X cubed. Okay, yeah, it's going to get repetitive here for a minute. What's x times x cubed? X to the fourth, good. What's x to the third times x to the fifth? X to the eighth. What are we doing every time? You're adding your exponents, good. Okay. You're adding your exponents because you are what? Multiplying what? Your x's, good. Okay. Also known as your variables, or another word for it would be, starts with a B. No, not that one. Okay, we'll get to that one. We'll get to that one. Keep that in mind. All right, bless you. Okay, so there's one rule. Now, what we're going to do on this slide here, there's 7 rules of exponents that we need to cover. Okay, and we're just going to kind of talk about how each one gets used in the problems. All right, instead of having a big slide of just the rules themselves, here's how they work. Right. So what if we had x to the 6th over x to the 2nd? What does that become? X to the 4th? Okay, that's what you would think if it was straight division, though. But remember, your exponent rules are different, right? Like over here, we didn't multiply with these, right? You just add them. So over here, we're not going to divide them. We're going to what? Subtract them. So it's x to the 4th. Good. Okay. So there's second rule. Okay. Everybody go with those two. Those are your two basic ones. Okay. Multiply your bases, or multiply your variables together. You add your exponents. When you're dividing your variables, you subtract your exponents. All right. Now, let's go to a couple of different ones, a couple harder ones. All right. Let's say you have x squared cubed. X to the 6th. Good. All right. What's 2 cubed? 2 cubed. 2 times 2 times 2, which is 8. Good. Okay. 2 times 2 times 2. I love how you said that. Good job. Okay. It's 8. Now put it to this. Okay. X squared times x squared times x squared. So you would make it look like one of these. Right? So x squared times x squared times x squared. 2 plus 2 plus 2. Or the shortcut, like we like to say, 2 times 3. Which is x to the 6th. Okay. So there's 3 of your rules. All right, and those 3 are probably the most common 3 that you need to know. Okay, most common. All right. Here come your other 3 not as common but still important. X times y in parentheses to the 3rd. Think about like we thought about this one here. X squared times x squared times x squared. These were squared, and these are not. These are to the 1st. Cody. X cubed, y cubed. Good. Okay. X cubed, y cubed. Okay. If you have a multiplication, everybody see that? All right. I know there's nothing there, but remember, if 2 variables touch, it's multiplication, right? Okay. Like that. And if you have 2 variables being multiplied together, and you're cubing them, you cube each one, right? xy times xy times xy. X times x times x is x cubed. Y times y times y is y cubed. Everybody good? In a similar way, that was terrible, X. Did you see that? That was awful. What's that going to equal?
Would it be the same thing?
Not quite.
Would it be X Y?
No.
It would be, no, it would just be,
Talk it out, Burke.
wouldn't it just be X, over Y?
Not quite, because that's what I got right here. X over y to the third. All right, Cody.
X cubed over Y?
There, y what?
Cube. Y cubed?
Y cubed. Good. Okay. X cubed over y cubed. Okay. Just like how you had it with a multiplication and you cubed each. See that? When it's a division, you cube each. Okay. So these two are very, very similar in fashion. All right. Let's see. 1, 2, 3, 4, 5. So there's 2 left. Okay, good. Making sure I don't forget one. Let's see. Let's do the easier one first. X to the 0. 1. Okay. What's y to the 0? 1. What's 8 to the 0? What's 12 to the 0? 1. What's anything to the 0? 1. All right. Anything to the 0 is 1. Okay. So these 3 are your main ones. Okay. These 3 are kind of your secondary ones, but they still show up. Here's your most complicated one. One over x to the negative third. Okay? Now, what we haven't talked about yet, but what we will next slide, is that you cannot have negative exponents. Okay, it can't be done. So we have to figure out a way to make this one positive. Alright? That's what we got to do. Now, I want you guys to look at this one right here. What do we do here? We subtracted, right? Okay? And I want you guys to look at this one here. X to the 0 is what? 1. Now let's go up here. Here's a 1. Can I write that 1 as x to the 0? Yeah, nothing wrong with that, right? Okay, so you make that be x to the 0 over x to the negative third. And now we're going to subtract like we did over here. See that? So what's 0 minus, be careful, negative 3? 3. But that 3, notice how we had this move up to the numerator over here, right? This one was over 1. So was that one. So what's the shortcut on this one here then? If it's negative in the denominator, it's what? Positive in the numerator. Alright, that's the shortcut. Now, what if it was like that? If it's negative in the numerator, using this same logic, flip it and make it positive in the denominator and under 1. Okay? Cody.
If you had the x cubed over 1, would that just simplify the x cubed?
Yes. Yes. Okay, everybody good? Those are your exponent rules. Now, to be honest with you, I think this lesson is one of, personally for me, it's one of the hardest ones to teach. Okay, because the rules are so, it's based on the rules, you know? And like this is a slide here you have to know. Okay? So we're going to take these slow. Like today we're going to do basic examples. Tomorrow we'll kick it up a little bit. And then next week we're going to do a few more worksheets to get this under control. And then eventually, I just didn't print it out yet. I have a spreadsheet kind of on your rules basis. Okay, so that way I'll get you guys that tomorrow. But it's very rule driven. the numbers we're going to work with aren't terrible. Like, you almost don't even need your calculators. But you have to understand these rules, these 7. Okay? Now, what these rules, everybody good with that? Everybody good up here? Okay? Now, what these directions will say is just simplify. All right? That's all they'll say is simplify. And what they mean when they say simplify are basically these 4 bullets here and then this definition. All right, to simplify, according to the book, means to rewrite the expression without parentheses or negative exponents. So no parentheses, no negative exponents. Okay, and then they give you 4 more bullet points down below to make sure you handle, all right? Number 1, no powers of powers. So like we did when we had x to the 2nd and then to the 3rd, and we made that x to the 6th, we have to do that. You cannot circle an answer with a power of a power inside it. Okay? Each base appears exactly once. What's a base? Close. In this case, it's going to be our variables. Remember how I said variable had a word that started with a B? Base. Alright? Each base appears exactly once, which means your x's happen one time in a problem. Your y's happen one time in a problem. Your z's happen one time in a problem. Each base happens once. All fractions are simplified. Simplest form, like normal, right? 4, 6, better get reduced to 2/3. Okay, nothing new there. And then no, it's so important they tell you twice. No negative exponents. Okay? Do not circle something that has a negative exponent in it because it's not done. It's an easy finish, but it's not done. Okay? Questions on what we're looking for here, folks? Everybody good? All right, let's do a few. First one. Simplify. In parentheses, 2a squared times 3a cubed. Now, at its core, and always look at this, at its core, what operation are you doing? You're multiplying, right? At its core, we're multiplying. Parentheses, touching parentheses means multiply, okay? Here's where this gets tricky. 2, this 2, and this is why I made this first problem this way. This 2 and this 3. Okay, let me get some colors. This 2, this 3. They have a fancy name. Does anybody know what that name is? If it had an exponent on it, yes, but they don't. No, not a base.
What letter does it start with?
C.
C-O?
Yeah? C-O-E.
Coefficient.
Coefficient. There you go. Okay? You have to keep your coefficients separate from this 2 and this 3, which is called your what? Exponents. Because see, your coefficient rules are always what they have always been. This is 2a squared times 3a cubed. What's 2 times 3? 6. That's a terrible 6. Thank you. But then when you have your exponents, you have a squared and a cubed. Now, since you're multiplying these two, a squared times a cubed, these exponents, you what? You add them. And make it a to the 5th. That's it. The number manipulation is going to be easier. The what to do, the when to do, the how to do. That's where this gets difficult. Okay, your numbers won't be large. It's everything about it, though. Okay, very quick focus on that one. Everybody good? So your second one. 2q to the 7th over q squared. Keep them pretty basic today. Let's see. Stokely. 2q to the 5th. Good. Okay. Notice how there's no number down here, right? It's just 1. So your 2 just comes along. And then you have seven q's up top, 2 down below. So it's q to the 7 minus 2 becomes 2q to the 5th power. Not stressful on the numbers, like I said, I'm going to keep saying it. Not stressful on the numbers. Okay, we can all handle 7 minus 2. It's just the when to do it. Okay. Questions on here? Go.
Have you ever had 2 on top and 7 on the bottom?
Yes, we will get there. Yes. Miss Pearson. Because you're right here and you're smiling.
I'm not sure.
You were. Until I called on you. X to the negative 12. Simplify. What's the problem with the problem? It's got a negative exponent. You're on fire today, you know that? No problem. It's got a negative exponent. How do we take care of that? Flip it.
So it's going to be
X. It's going to be 1 over. See how it's in the numerator? Okay. Now here's the trick. Here's what you have to recognize. This is technically in a numerator, right? Because it's over 1. If there's no denominator there, that means the denominator is 1. So it's in the numerator right now. So then when you go flip it, it moves it to the denominator. Okay. X to the 12. Okay. Now let's go off a little bit off of from what the slides say. Let's go a little. We'll take a little detour. Let's say it was x to the negative 2nd over. Or here, let's do this. Let's do 2x to the negative 2nd over y to the 2nd. Here's what you look. Here's what you look for. Okay. First thing. Do all of my bases happen one time? Yes, each type, right? X happens one time, Y happens one time, 2 happens. All right? You check that. Second thing. Do I have all positive exponents? No. Now, be careful here. Which exponent is negative? The 2 that's on the X. Okay, the 2 that is on the X. To fix that, you move it to the bottom, the denominator. So what's your answer?
2x. No, 2x. 2x squared.
You didn't move it though.
2x y squared.
No, I flipped it, but you keep would it be, you just flip the 2, or would you keep the y at the bottom?
Here's my question. Is your exponent on this 2 negative?
No.
No. What is it? It's positive 1, right? So this 2 stays here. Okay? See, these are only connected by multiplication. All right? Without getting too technical, you can separate these 2. The only thing you got to move is the x. Move it down, make it positive. So this one, 2 over x squared y squared. Okay. Let's get one more. Let's get Cody's question in there too. All right, let's see here. How about 4? That was not a great 4. It wasn't a terrible 4, but not a great one. 4y. Let's see. Let's go square over 8y to the 5th. Try that. Okay. Same questions. All right. then you got to ask yourself these questions at every step of the way, because if one of them, you can possibly change your answers from one step to the other. For example, do my bases happen one time? Let's try that again.
Yes.
4y squared over 8y to the 5th. Did I say a letter twice? Yes, I said y twice, right? So that means no, they don't happen twice. So we got to clean that up. All right, so since it's division, we have y squared over y to the 5th. What do we do with these exponents? Subtract. So if you haven't picked up on this, because we haven't gone this difficult yet, what you always do top minus bottom, right? Everybody picked up on that? Top minus bottom. So we do 2 minus 5 to give us what? -3. Good. Okay, so we have 4y -3 over 8. Now, once again, every single problem you had to ask yourself those same questions. Okay? We go through them. Do my bases happen one time? Now that answer is yes. See that? Okay? Well, y happens one time. Second question. Are my exponents negative?
Yes.
There is. So we got to move them back to the bottom. Okay? See how that works? 4 over 8 y to the cube. Y to the cube. That was silly. Y cubed. Okay? So, of your rules, do my bases happen one time? Yes, they do. Do I have negative exponents? No, I do not. Do I have powers of powers? No, I do not. What's the only thing I haven't done? Reduce. Cody.
Why wouldn't the 4 and
Because your exponent on 4 is 1, your exponent on 8 is 1. Okay? They're not together. All right? We'll get into some tomorrow whenever you have exponents on the coefficients that are negative. Okay? So, the only thing we have left to do on this one is reduce. 4/8 becomes 1/2. 1/2 y cubed, not squared. X to the 4th to the 6th. What does this one become? Not x to the 10th. X to the 24th. Power to a power, so you do what to those powers? You multiply them. Good. Okay? X to the 24th. All right.